All right, welcome back to the Nexus Podcast. Checkpoint researcher Shahar Tal joins me to talk about some significant security issues in popular AI agent frameworks. The Checkpoint research was presented at Black Hat recently, and that's what we're going to spend some time talking about today. Before we do, my usual reminder to subscribe to the podcast. I've got a bunch of episodes coming up that were recorded at Black Hat with researchers, speakers, and a few other folks. So if you weren't able to make it to Vegas or just miss being in the desert, please subscribe to the podcast and we'll definitely bring you back there. So let's get started. How are you? Good to see you.
Good to see you too. Great to be here. Thanks for having me.
Why don't you tell the listeners a little bit about your role and kind of your day-to-day?
Yes, no, absolutely. So my name is Shahar Tal. Quick 2 decades in the cybersecurity fronts, starting out with 1 decade in the Army. So that was Air Force, then 8200. After which I joined Checkpoint, actually. That was 10 years ago. And I led malware and vulnerability research back at the time. Then I joined Celebrite. I led the company's research for about 8 years doing digital forensics work. Super interesting work, but maybe that's for another episode. Then, together with 2 great friends of mine, Baruch and Dror, we co-founded Sayata, where I was the CEO. And that just 6 months ago, we were acquired into Checkpoint. So kind of a homecoming for me. But an amazing ride. And we're here now. So today I am the head of Agentic Security Innovation right here at Checkpoint. And this research was done by Yarden Porat, who's been a security researcher, who has been with Sayata from the very early days as well, has been doing some really, really interesting research, and we worked on this for many months together.
Security is just a big circle. Eventually you work with everybody and work for a lot of different companies.
No, absolutely. It's a big pond.
So let's talk about your research. So I attended the session that you did with Yarden and on post-injection exploitation across these AI agent frameworks.
Yes.
Maybe let's just start at the beginning. Just kind of take me inside some of these frameworks. I think you looked at 4 or 5 specifically.
Yeah.
What are they used for? And just kind of bring the listeners into that.
Yeah, no, absolutely. Over the past year, we audited some of the frameworks that the industry is building its agents or AI agents on. And these are LangChain, LangGraph, Microsoft's agent framework, Google's, ADK, Cloudflare's code mode, CrewAI. And with these frameworks are used when, you as a developer would want to write your own agent, right? So you need to build it on top of something. We've seen a lot of AI agent exploitation in the last, couple of years. Lots of prompt injections trying to persuade the agent to do something else than it intended. And then we've seen a lot of kind of topical tool abuses where you find a vulnerable tool, a specific misconfigured or something that can be injected into, and then you use that tool to gain something as an attacker. But we thought about this layer of infrastructure that we are all growing to rely upon. And we said, well, what if we found problems with the infrastructure itself, right? That would mean that, if there was a problem there, it affects every agent, no preconditions, no required tools to be installed. No, it just comes out of the box. That was, what we set out to do. And we kind of had the feeling that this was underserved, right? We saw very little research into those frameworks. And eventually that was true. So, let's say we cared enough to report 21 findings, and were assigned 12 CVEs by the end, the end of that research. Many of them critical. Pretty much every framework we hit was was had a very significant finding. Um, and yeah, so there were a lot of kind of intricate technical stories around each of them.
Sure.
But I think the overall understanding is something that we think we should, put more light on, is the fact that we are building these AI frameworks faster than we know how to defend them right now. Okay, we're building this very fast, and we're trusting it with a lot, trusting it with access to everything that we know. We're trusting it sometimes when we're making financial decisions and in the enterprise as well. Um, but we haven't given it kind of the 3 decades it took us to trust browsers or some of these other
Right.
web frameworks. So I think it's, for us, it was very surprising.
You mentioned you found 21 issues, 12 CVEs were
Yeah.
assigned. Take me through some of the vulnerabilities in terms of criticality, in terms of ease of exploit. Who would go after some of these?
Uh, yeah. So I think interestingly, what we found is a lot of, I'd say, classic vulnerabilities, right? The bug
Mm,
classes that we know of, that we've known how to deal with for 20 years. And like memory corruption vulnerabilities, right? Like use after freeze. We found insecure deserialization in, like, repeatedly, actually, across a couple of frameworks. Um, and so that was, again, something that we were surprised to find, because we thought, everyone's looking at how to attack those models and how to extract their deep thinking, reasoning traces, and we're not looking at the basics. Now, if we were to look at one of them, you know, we looked into LangChain, and LangChain is by far the most popular open source
right.
AI agent framework, with like 300 million monthly downloads. Um, and so this one, we to understand it, we need to kind of, you know, understand how it serializes its state and stores, kind of JSON blobs, which means what it remembers, what tool calls did it make, etc. And as we were doing that, we were looking very carefully at how it's constructing and reconstructing those classes. And kind of a classic issue that ended up surfacing is what we call insecure deserialization. So what we were able to do is tell it to store some piece of data, and something that's very kind of, I'd say, simple and non-malicious.
Hmm.
When it deserializes, it's going to instantiate an arbitrary Python class that we as an attacker can control. And so what that means is any agent relying on LangChain, right, could have been attacked using this technique, regardless of any tools being installed or not. All it took was for it to serialize and unserialize its memory, right? It doesn't matter if it's on disk and SQLite, or many other kind of formats. Where would you, as an attacker, exploit this? Well, you know, I think the industry kind of collectively understands this is a grand security problem, because
Sure.
agents have all the permissions in the world. We want them to be useful. We give them all the permissions in the world. We give them access to data, and so anything that the AI agent could potentially access and perform, attacker gets access to that directly. And in fact, because this was a remote code execution rather than something just internal, we could use it to laterally move about the victim's network, or take over other agents or other enterprise software that are sharing that infrastructure.
Right. So is there a level of trust that's being exploited here? Like if how are we going from injection or exploit to the trusted logic, I guess is what I'm
Yeah,
asking.
so in this case, it's we're using kind of a simple trick, we're just asking the agent to, to call a tool, and give it the parameters, which isn't something malicious per se, right? You couldn't say, well, it doesn't necessarily gets blocked by a prompt injection classifier. It's something that's relatively innocent. But the way that tool call is, constructed or deconstructed is what makes it malicious. The trust we're exploiting is inherent trust in AI agents that everyone is sharing right now. It's just something that it's not. This is not specifically new to our research, right? We all know there are these problems. We just need more time to fix, to patch those vulnerabilities, to build the resilience into those pieces of infrastructure we all rely upon.
And so the payloads, if I recall from your session,
Yes.
um, they were being embedded in either PDFs or images or something like that, trusted that would be injected
Oh yeah,
into the
that's
prompt. Am I
that's
oversimplifying?
yeah, no, that's yeah, that's another one
Yeah.
where we found something so simple and classic, which is, which also affects the indirect prompt injection route, which means just pointing an agent at at any document to read or to sort through, would cause this document to get parsed by a vulnerable PDF parser, that we found there, laying around since 2005. I think it was interesting for us also to see how, even the developers for CrewAI, which is the specific one, um, I don't think they realized that when they're using this library and calling the function get text, that it's actually going about, parsing images, fonts, decompression, actions, all sorts of things, even though they just wanted to get or to extract the text out of the PDF, right? So that's something that, again, kind of a classic, right? We know those seams between, the calling some, like, older functions, insecure parsers. Um, they've been there throughout, but still we're writing them there very fast. They don't get enough scrutiny, and we're trusting them too fast. So that's, yeah, that's part of the problem.
Right.
Now I've been actually this, and I think this is an interesting point. Um, when I said this, I was discussing with a couple of my colleagues, and one of them said, "But wait, but what? There's all these AI models are finding vulnerabilities in code bases, um, and fixing them very, very quickly." And that's true, and that's the optimistic part in all of this. Like, looking forward, I'd say yes, this is going to happen, but it's still very far from happening in all code bases, right? So you need a lot of human maintainer attention to enable this amazing vulnerability finding and patch management cycle in a code base. And I think it's going to take like 1 and 2 and 3 years until the majority of significant code bases has embraced and adopted such cycles. With pretty much all of the code bases that we've audited, we haven't seen that yet.
Interesting, because just the speed of the last 6 to 9 months has just been ridiculous, and I'm sure you're much more aware of it than we are.
I am living the dream. Listen, it's, you don't get to live through a lot of revolutions, but
Right.
sometimes, you feel it, and you see it happening, uh, and the rate of change is very high. Yeah, it's exactly what's, again, causing some of these exposures is exactly this rate, where, we need a few years to get oriented around what's happening and make sure that it's secure,
Hmm.
but we're using it. I think like 18 months ago, we didn't really know what this is going to look like,
Sure.
and today, all of us are kind of, asking ChatGPT in our pocket to do things for us, or you know, asking them things about our health, our finances. And again, this, I don't want to be an alarmist, because I think it's a very good direction to go. That's the way technology should advance to. Um, but in many environments, we still need to get more resilient.
In the grand scheme of things, where do these vulnerabilities and these frameworks stand compared to other AI related vulnerabilities and security issues?
Yeah, you know, I think we're seeing a lot of headlines.
Yeah.
There's a lot of good coverage around the newer fancy AI attacks, attacking a model, bypassing some prompt injection filter. Um, and I think, we're going to continue reading about a lot of agent failures this year, but very few of them will be the model's fault. And I think models are getting to a point where some of the internal defenses are are quite reliable. I wouldn't say 100%, but they are
Hmm.
getting much better. And specifically after the whole, Anthropic fable kind of, incident, they got it to a point where it's very difficult to get it to do something. It's cybersecurity related, at least. Um, and the self-hosted models are out of the question. So at least in that area, I think we're going to see more of the failures happen, not because of hallucinations, not because of a problematic SaaS side guardrail, but because of these vulnerabilities, and because of people um, failing to place the right defense in depth. Okay, because guardrails have been debated to death by now, and I don't think still I don't think people know exactly what they should look like, because there's lots
Sure.
of guardrails. Um, but everyone understands you need them, and you need um, a few levels of them, because once you bypassed one, sure, that's going to happen. But what about the other two guardrails that are there? Um, and so it's a defense problem, really, rather than a model problem.
Hmm. We should probably talk about the risk involved here and
Mhm.
around the vulnerabilities in the frameworks that you guys found. Excuse me. Just how useful are they for an attacker? What would an attack look like? Explain what an attacker could control, etc.
Yeah. So in many of the cases, it was just remote code execution. That's the holy grail, right?
Sure.
If you are an enterprise running your agents, and you think you're doing the right thing by self-hosting it and making sure you use the latest and greatest, AI frameworks. If someone were to exploit one of your agents just by, a user speaking normally to an agent, you don't need, that's another interesting difference in history. An attacker needed, like, a sometimes like a non-standard attack surface, right? It's like an API through some means to be open, or some port that they could speak to. With AI agents, this attack surface is just speaking to a chatbot, which is exactly what we're building the agent for. So that's it. It gives you this concentrated funnel where attackers get to try what they have. And so if an attacker can exploit this, then they are in, quite literally. One, everything this agent ever did, any conversation that anyone has ever had with this agent, but also anything this agent could potentially do. And then also the lateral kind of infrastructure move that
Sure.
I said before. Um, and and so that's what one was really interesting with another case where we found kind of vulnerabilities in Cloudflare's infrastructure. And I think that was the other talk, because you attended maybe the post injection talk, but we also had
Right.
a Cloudflare code mode um, presentation. We were able to break the basic promise of of Cloudflare workers, where a worker is supposed to be secluded from other tenants on the same machine. And we were able to break through that and pretty much get any secret from any tenant running Cloudflare code, right?
Sure.
That was actually much wider than the code mode element. We started out by researching code mode, but we ended up with Cloudflare workers, which is kind of the underlying runtime that code mode relies on, but it affects much more than the agents. But anyway, that one was very simple for an attacker to exploit. Just send this arbitrary JavaScript to a worker where that's something very normal that you're supposed to do, um, and that would exploit the server side
Hmm.
for that Cloudflare instance.
To go back to the previous discussion in terms of the fixes, when you hear architectural problems, you
Yeah.
think of kind of code overhaul, huge problems, to a huge project to fix these things. How difficult were the updates, et cetera? What can you tell us about
No,
that?
I will say that most of the issues were simple to fix in that, well, there was a missing check, or they had a wrong calculation for something, which is kind
Yeah.
of the classics. um, in some cases, like in Microsoft's agent framework, they actually decided to rehaul the entire serialization and move away from whatever deserialization logic they were doing to something, I think, to pickle or something like that. um, and that was interesting for us as well, but it was also like a pre-GA version, so things are going to move around,
Sure.
and it happens. The rollout itself is also not very complicated. Once people know there is a vulnerable version, you roll out the version, you need to deploy it, just like your every piece of software where you do your patch management cycles. um, that that would be it. One interesting uh, exception to that was the Cloudflare instance, where we got two criticals. They confirmed it. They paid respectable, generous bounties for the findings, so like in recognition for the work. But at the end of
That's a
the
good
day,
thing.
what?
That's a good thing.
Oh yeah, no, we actually got that from all of the vendors, and that's nice that they're showing the recognition. But the thing was, with those findings, they did assign them criticals, but they chose not to assign any CVE, and that was a bit puzzling for us. We kind of went in a back and forth. Eventually, they said that it was a project policy not to issue CVEs or advisories, which I would say it's not unprecedented. I've seen maybe a couple of projects, maybe like more, it's more of an internal project. But we think it's the wrong call here, specifically because worker D, or this runtime that powers workers, is also distributed for self-hosting. It's distributed in npm, and so if someone downloads a package and they kind of pin the January version before our fixes, they will never know unless they hear the news that
Right.
there were critical vulnerabilities in this version, and that were fixed in the version where all of our vulnerabilities were fixed is 2026 0616, which is like the June 16th one,
Hmm.
um, or June 19th. But again, if you look at the release notes, there's nothing there's nothing there, no
Yeah.
advisory or no credit. So again, there some of the areas here, we saw a bit of friction, but that was it.
That's unusual, though. That sounds a bit 2002 kind of.
I mean, yeah, it is unusual. We think thought it was the wrong call. It's not like we need the numbers, or we don't count CVEs, but forget the CVEs. Let's have an advisory in place to make sure
Right.
people know something for those debug bots, the trivies of the world to pick up on
Hmm.
and let you know in this CI/CD cycle that, hey, you should update that library. That's all.
Yeah. What what about enterprise security teams? What should they be doing about, for example, the issues in these frameworks? Or is it just a matter of kind of relying on the vendors and the maintainers of these open source projects to adequately communicate and fix, etc.?
I don't think anything changed in the threat model. Um, and everything that was correct yesterday is correct today.
Hmm.
Make sure you know try to use the latest versions. Make sure you employ defense in depth, list privilege, any like everything is very take your old model, point it here, apply it carefully. Um, we just have to we like looking at prompt injections and then preventing prompt injections, and that's great. It's important, and that's a critical runtime guardrail. But at the same time, we have to assume the injection is going to happen, and then let's budget for that world, right? So
Right.
don't laser focus all of your energies and and defenses at one layer. There's a defense plane to be you know to be layered here.
Okay, so just to wrap up, and it's going back to a comment that you mentioned earlier. We're kind of in a revolution here,
Mhm.
and obviously there's a lot of new innovation. There's a lot of speed here. Does it need to slow down, and or will the whole nature of AI and these models allow it to slow down? I mean,
uh,
are
so
we okay?
yeah, my answer is twofold. I mean, one, it doesn't need to slow down, and two, even if I thought it should have, or even if anyone in the world thinks it should have, we are not at a position to make that call. The world is going to move.
Sure.
The world is going to adopt faster than any of us can think about it, um, or control. And so this is happening. Make sure you put your best defenses, security thought, critical thinking into what permissions you're giving, what actions are you allowing AI to take, um, and if your risk tolerance is lower, then don't take all that risk.
Right.
I think it's really comes down to basics. um, I am so excited to be living in these times, and I just want to see what happens in 2 years.
All right, Shahar. Thank you so much for coming on the podcast. I really appreciate it. It's been really very entertaining, very good stuff here. So I'm sure the listeners are
Absolutely.
going to love it.
Thank you so much. All of the credit here is really to Yarden, who's done a lot of amazing work.
Yes.
We're working on some new stuff. Hopefully, we get to record another episode sometime, in a few months.
Yeah, let's stay in touch. Let's stay in
Absolutely.
touch.
Thank you so much.
All right. Thanks again.
Have a great rest of your day.